What you're looking at on the screen is a simple method. Truncate A in first two positions. What this method does is if you pass any string to it, so I'm passing in AACD is an example string, so it checks the first two characters to see if any of them is A. If they are A's, then they are getting truncated. So here I have A's in first two positions, those are truncated and removed from the string, and the output is CD. If you consider this particular string CDAA, this does not have A's in the first two positions, so there's no change. And similarly, this particular thing, it has A in first position only, so that gets truncated and remaining string remains as it is. So that's basically what this method does. I mean, in a typical application, there would be hundreds of methods like this, doing some business logic or the other. Let's say this particular method is part of a large web application. So you have a large web application where this method is being called from somewhere, and somewhere, let's say this particular value is shown on the screen. So the output CD is shown on the screen somewhere. Let's say that's the fifth screen in a web application. I want to check whether this is working fine. The traditional way of doing that is this Java file would be part of a big web application. So I would build a var, deploy it to a web server, and then navigate to the specific screen and check whether the output is coming properly or not. That's the traditional way we used to do it. And now, if I want to check whether the next test case is working, I would manually go there and check whether the output on the screen matches whatever I expect. Let's say there's a small change in logic. So now, instead of this, I found that there's a defect and I'm making a change in the logic. Now, to test these scenarios again, I have to go through the steps, all the steps that we discussed until now, again, manually. And that's where the unit testing comes in. Unit testing tries to address this problem. So when we write some business logic in a method, in a unit, we try to test the unit on its own. So this particular thing is a unit. I would pass in AACD and check whether the output is CD. I would pass in CDAA and check whether the output is CDAA. So I would test this unit on its own. And that's one of the most important concepts of unit testing. So in unit testing, you try and test a specific unit. The unit can be a single method, a group of methods, or it can also be a set of classes. Typically, in most scenarios, when we talk about unit testing, we would be talking about testing a method or a specific group of methods. The advantage of unit testing is that once I write a unit test for this particular method, I would be able to run the unit test automatically within milliseconds and check whether all the test conditions for that particular method are matching or not. Or the right words would be if all the test conditions for that particular method are passing or not. Now that we understood the need for unit testing, we would start with the first unit test in the next section. Let's now begin with our first unit test. What I'll start with is I'll start creating a new project. So I'll start with file, new. Instead of selecting file, new project, I would do something different. I would do file, new Maven project. When we write unit tests, there is a specific project structure that we would need to create. And when you create a Maven project, that structure gets created automatically. Maven is a Java build tool which automatically comes along with Eclipse. So we would be using an embedded Maven inside Eclipse in here. You don't need to really worry about it because all these kind of things happen automatically. So I do file, new Maven project. How do you come here? Let's do it again. So it's file, new. You have to click other and type in Maven and select Maven project and click next. So I would want to go ahead and create a very simple project. Archetypes are Maven's way of creating sample projects. So let's say I want to create a sample project for Spring MVC. The archetypes help me to create a sample project for Spring MVC very quickly. Here we are just creating a simple Java project. So I would go ahead and choose only create a simple project. I don't need to select an archetype. And you can leave the default workspace location in as it is right now and click next. One of the things about a Maven project is you need to give a group ID and an artifact ID. So I would go ahead and give a group ID com.in 28 minutes. You can give anything that's valid in here. And the artifact ID is I'm going to learn about JUnit. So I'll say JUnit course in here and say finish. You'd see that a small project is created which you can navigate through in the package explorer and see there's a source main Java, source stage Java, and a few other folders created. Don't worry about them. We will learn each one of them very soon. We want to write a unit test. So for being able to write a unit test, we need to have a small piece of code that we would want to write the unit test for. All the code which we would use during this particular course is part of the repository JUnit in 28 minutes in 28 minutes. So it's github.com/in 28 minutes JUnit in 28 minutes. You'd find the link in the resources as well. If you go further down from here, you would see the piece of code that we would use to start writing tests. I mean, this is the piece of code that we would want to test. So this is the code. I mean, we have a couple of small methods in here, truncate A in first two positions and our first and last two characters the same. We would want to write unit tests for these two methods. So you can copy this. So I will select this, do a Control C, and we would paste this up in Eclipse. I'm doing a Control C to copy the code from there, and you can do right click and paste in here. There's some magic which is going to happen now. I'm copying a piece of code and pasting it in here, and Eclipse automatically creates the file completely. So the string helper is now available for us to write the unit tests for. So I would want to write the unit tests for this particular method, truncate A in first two positions. As we discussed earlier, what we want to be able to do in here is if I pass in a string which has A's in first two positions, it should be truncated. So AACD would be giving an output CD. ACD, because there's only one A in the first two positions, that gets truncated, gives an output CD. And let's say there is a CDEF, there is no A at all anywhere, so it would remain same. And let's think of an example which does not have A in first two position, CDAA. So A is not really in the first position, it's actually in third position and fourth position, so those don't get truncated. So this is the unit test that we want to write. So I would want to pass this this input to this method, and I would want to check whether the output matches. How do we write a unit test for that? So that's basically what we are going to do right now. We want to now write a unit test for this particular method. The first important thing about unit testing is the unit test code should not be mixed with your source code. So the source code is in the folder source main Java. I don't want to create the unit test also in that particular folder, because if I put test files also in this particular folder, then when the jar is built up, the test files would go along with the code. I don't want test files to be with the code. I would want them to be separate, and that's why we would create them in the folder source test Java. So I'm going to go into source test Java, and I would go and say right click, new JUnit test case. Right click, new JUnit test case. What I would start off is selecting class under test. So the class under test that we would want to use, what is the class that we want to test? String helper. So I would put string helper as the class that I would want to test. So class under test is com in 28 minutes JUnit helper string helper, and typically we would create the test file in the same package. So I'm putting it in the same package. So the package is same as the class that we would want to test, and the name of this I would want to have the class name. So string helper is the class that we would want to test, followed by test. This is kind of a simple convention There are complex scenarios where you write multiple test classes for the same class. In those kind of scenarios, you would have a different naming convention. But to keep it very simple, we would say class name followed by test. That's kind of the convention that is followed in most of the projects. So we give the package name as the same package name as that of the class, and the name of the test itself is string helper test, and the class under test is com in 28 minutes JUnit helper string helper. Those are the inputs that we would give and click finish. If you see this particular thing, it's asking me JUnit 4 is not on the build path. Do you want to add it? Ideally, we would need to go into the pom.xml and add it in, but since we are just starting, we would take the shortcut and say add JUnit library to the build path. So we would go ahead and add JUnit 4 library to the build path, click OK. Aha! Now you have your first unit test in here. Now you can do a right click, run as JUnit test, and you see the famous JUnit red bar. So this JUnit red bar is saying that there's a problem with the test, but the good thing is you are able to run a JUnit test, you have the source code set up, and you have the sample first unit test set up as well, which is not really working, but you have something going. In the next section, let's look at how to really write a unit test for the string helper class. We now have a small test which is failing. So let's see how to really make it to succeed. What I'll do is I'll remove this particular line. So I'm removing the fail in here and I'm running this test. So it's the same as earlier except that I removed the fail line and I'm running this test. And there you go. You have your first successful JUnit test. I'm not really testing anything here. The point we would want to illustrate in here is the fact that a test is successful if there are no failures. That's one of the most important lessons in JUnit test. In JUnit test, in any JUnit test that you write, if there are no failures, if there are no expectations that are not matched, then it means the test has succeeded. Earlier, when we ran this test, we had a fail method in here. If we look at the imports in here, let's quickly take a look. So what we are importing is at test. So the at test annotation is defined in the package org.junit. So that's the unit test which says this is a specific test method. So this is going to be a test method that's specified by at test. Fail is one of the methods in a series of assert methods that JUnit provides. A fail would normally fail the test. So this particular test, when I run it, it would fail because this is the first line that's executed. So this is fail. Now let's write a better test than fail. What we'll do is we'll want to assert something. So I would want to check whether couple of values are as expected. So the way you do that is by using a sequence of assert methods. So if I want to, let's say I want to compare if two strings are equal. So assert equals is a method which does that. Type in assert equals and press control space bar. There should be a lot of suggestions which should come in. I would want to compare whether two strings are equal. So what I would do is I would say assert equals ABC and I would pass in something else in here, ABCD. So if now I'm saying assert equals ABC comma ABCD, let's see what would happen. Aha, another test failure, another red bar. If you look at the string, it says expected ABC but was ABCD. So I'll just copy this whole trace so that we can relate to it very easily. So right click, copy trace, and I would go back to the test and paste this in just so that we can check the result. I am not really worried about rest of the thing. So I would, it's JUnit comparison failure. What has failed? It's saying expected ABC but was ABCD. So that's your first thing. I mean, the asset equals, there are two arguments which are passed. The first one is called expected and the second one is called the actual. When I write a JUnit test, I have an expected value as well as the actual value. The actual value is the result of whatever operation that we would want to do. So here the actual value is what is the value coming out when I call this method with an input. That would be the actual value. The expected value would be the value that I would want to expect. So what I'm expecting is the expected value. So when this test failed, it's saying expected this but was this. So that's very good in the sense that for debugging it's very easy because JUnit is telling us exactly what is not matching. That's really good. Now let's go ahead and change this test to say asset equals ABC comma ABC. Aha, that really works. So you'd see now that the asset equals method is really working. So you'd see that when I pass in the same values twice, the asset equals passes and it results in a green bar. However, when I pass different values, it results in a failing test. In truncate two positions, I would want to pass in a value AACD and check whether the output is CD, right? So first thing I would want to create an instance of the string helper because this is not a static method. I would need to really create an instance of the string helper. So string helper, I'll just call it helper is equal to new string helper. So I'm creating an instance of this method and I would actually now do helper dot, I would want to test the truncate A in first two positions method. So I would use that truncate A in first two positions. And the first input I would want to pass, I'll just copy these inputs in here just so that it's easy for us. So I'll go ahead and copy them in here. Among the first conditions that we would want to test is I would want to pass in an input AACD. So AACD. So I'm passing an input to this method and there is a result coming back. So what is that result? The result is the actual value. So the actual value is whatever is coming out of here. What is the expected value? I mean, what is the expected output that we have? The expected output that we have is CD. So I'm going to put that in as well. So is equal to CD and I would actually, so the first argument is expected. So for asset equals, the first argument is expected, so I would put the expected value. The second argument is actual. So now what I'm doing in here is now really calling the method with a value a cd and checking whether it's working fine. So let's do run as JUnit test. Aha, works. So basically what is happening is this method is called, the actual output would be CD, the expected also is CD, so this particular unit test succeeds. I actually created a lot of instance variables to really make it easy for you to understand. But when I really write this test, the test would look something like this. I'm using an inline variable. You can do a right click, refactor, and inline. So basically what the inline does is it removes the variable and replaces wherever that thing is used. So I'll do inline and it's asked me inline one variable actual. I'll go ahead and say okay. Please do play around with inline to understand it very well. It's very useful because now the complete thing is gone. I mean the variable is gone and this code is replaced in here. I'll do the same thing on expected as well. So right click, refactor, inline expected. So you'd see that the expected value will be removed and be replaced with CD. So you'd see that CD is now the output present in here. So now I have asset equals CD comma when I call this method AACD. So let's right click, run as JUnit test. Aha, it succeeds. That's very good. So let's go ahead and write one more condition in here. So I would take ACD is, I mean, most important thing, CD is the expected. So CD is the expected, the input is ACD, sorry. For ACD also the output is CD. So that's one important thing that you always need to remember. The expected value is first. So the input and the execution is on the right side and the expected value is on the left side. So the first argument is always the expected value and the next one is the actual value. What you can try and do is send two different values in here and see how the JUnit framework prints the not matching exception. That would really give you an idea about why the first value should be expected and the second value should always be actual. Even though you reverse them, the result is the same. However, when there's a failure, the message which comes up makes sense only if you pass in the first value as expected and the second value as actual. Let's right click, run as JUnit test. Aha, that's good. So we have something working in here. We wrote a couple of conditions for this string helper class, but it's not the cleanest code possible because there are a lot of JUnit good guidelines, good JUnit guidelines that we are not adhering to in here. In the next section, we would look at how you can make this unit test much better and adhere to more unit testing standards. This is where we left off in the previous section. We had a small unit test which was working. When I run this, it does work. It shows a green bar. But there are a few things which are not really good about this particular test. Let's start with them and let's improve them. So, first thing is the name of the method. Test. Aha, what is it testing? It's not really clear, right? Let's make it more specific. The fact that it's testing the truncate A in first two positions method, I would make it test truncate A in first two positions. So now it's at least clear what method it's testing. When you go more advanced into unit testing, you would actually go in and specify what condition you are testing as well. So you would say test this particular method, which condition am I testing? So am I testing condition 1 or condition 2? You'd kind of give a business related terms to test to give a name to that particular condition. So let's say if I'm in a banking scenario, probably I'm trying to withdraw amount and checking whether balance is fine. So I would say test truncate A in first two positions. Aha, doesn't really make sense, but you get the drift, right? Test truncate A in first two positions when amount is withdrawn, something of that kind, which gives a significance of the condition being tested. The other thing that we are doing in here, which is not really good, is I'm testing two conditions in the same test. Because this is very simple test, it's okay because now it remains readable, and if it fails, I would be able to debug relatively easily. But when you are unit testing complex scenarios, it's not really good to have two conditions tested in the same unit test. Ideally, you need to create another test. So how do we create another test? So let's go ahead and do that right now. So at test is how we add in a unit test. And the most important thing when we add in at test is the method should be public and void. No other signature is acceptable. So if you try with any other signature, the unit test will not run. So let's quickly do something of this kind. So test2, and I would run this test. Because it is public void, it would work. But let's say if it was, let's say, public string something and it's returning something back. Can I run this test? Nope, it's not really allowed. If you see the exception which is coming up, it would say test method test2 should be void. So you cannot have a return type for the test method. So it should be void, and the other thing is it should also be public. If I remove this also and try and run this test, the output, the error we get is method test2 should be public. So any test method should be public and void. The reason it should be public and void is because some framework should be able to call it, and the framework would be in a different package compared to the test, and if it's a default status or a protected status, it's not sufficient. It has to be a public method. So now in here also we want to test the same thing. So we would actually really make this test for now. Test truncated A in two positions 2. This is not really good thing to do 1 and 2, but let's quickly do it and refactor it a little later. So I would want to test the second condition in here, so I'm moving the code out. So string helper, and I would actually copy the code in here assert equals. So now we have the second condition being tested in the second method. The good thing about this is when this test fails, you would know specifically which condition has failed. So now let's go ahead and run this test. Okay, there you go. So you see the green bar. However, when you look at it in detail, you'd see that there are two tests which are run. So test truncate A in two positions, test truncate A in two positions 2. So that's the reason why you had a green bar with two methods, because we now created two methods. Actually, one of the things which we can improve in this is the naming. So test truncate A in two positions. Which condition am I testing? So I would call this A in first two positions. For the simple test that we are writing, this might be an overkill. But in real world business scenarios, it's really this results in really maintainable code. So if you have a test method underscore the name, the condition that you are testing, that results in really good maintainable code. There is a specific section that we have in writing maintainable unit tests where we will look at this in more detail. So this has only A in first position. So now run this test and see what happens. So this test succeeds. If I highlight a method and run the test, it would test only that particular method. However, when I do a right click, run as JUnit test from here, it would run everything. So it would run all the tests in that particular thing. Now you can see that in this particular test, A in first two positions, A in first position, both tests are succeeding. The reason why we stress on having two different tests for each of these conditions is that if let's say this test failed, so instead of expected, like let's say I'm expecting CDA in here and not the correct output, so what would happen is you'd see that there is a condition which is failing. So JUnit says there's a condition which is failing, and it would also tell you which specific condition. So when I read the test, I can say in first position test is not working. So what might be the logic that's going wrong? It already gives you a clue as to what might be really wrong. So I would go back. The other thing you would have already noticed is that there is a small duplication in here. So string helper, why do I really need to create it twice? The same code is repeating twice. So how do we really avoid this? I can actually create an instance at the class level. So I would remove it in from here, and I would create an instance at the class level. Now I don't have any duplication in here, and this is probably one of the cleanest tests that you can write for the example that we have. I would leave writing the next two conditions in here as an exercise for you. So try and go ahead and write test methods for testing these two string inputs and seeing whether you can write your unit tests. I would really recommend playing around with the framework in here a little bit. So try and create as many tests as you can. Try play around with it. Use assert equals. Pass some dummy inputs that you would want to pass and play around with them, and that will really give you a really good understanding about the unit test. Let's quickly revise whatever we have learned in the previous section before we start with our new examples. The first thing is that for writing a unit test, we use an annotation at test. So on any method which is public void, so a method should be public void, and we put an at test annotation on it. The test is defined in the package org.junit. So we use that at test annotation to signify that something is a unit test. The most important thing about any test is it should be public void. We use assert equals to check whether two values match. the assert equals would throw an exception if the values do not match, and that's how we write JUnits. So in an assert equal, if the values passed are different, then it would result in a failing test. Then the test is said to be failed. The other most important thing that we discussed until now is the fact that if there is no failure, I mean, if I don't have any condition in the test, this means nothing would fail, right? So when I run this test, there would not be any failure at all because there's nothing that's being tested. The most important thing in here is the fact that absence of failures is success. So in a test, if you don't really test anything, then it will always succeed. So that's a very bad test because this would always succeed. A good test is one which would test something and would fail when the condition which is being tested does not pass. So if I'm passing A, C, D to this method and it does not return CD, this assert should fail. If that doesn't happen, then this is not really a good test. So that's a quick recap of whatever we have learned in the previous section. So until now, we looked at what is JUnit, why unit testing. We understood the add test annotation and we saw how to run a JUnit test. It's very simple, right? Right click, run as JUnit test. And we saw that no failure is success. And we looked at the basic assert method, which is assert equals. Now, let's move on to the next section where we would talk about our second JUnit example. Now, let's start with the next section. We wrote the unit test for the first method in string helper, right? Truncate A in first two positions. Okay, that's good. But let's now go to the second method. This second method, let's quickly discuss what it does. As you can see, the name of the method is are first and last two characters the same. I think it's very simple, right? Are the first two and the last two characters of a string the same? So what I want to check is in a string, let's say it's ABCD. In ABCD, first two characters are AB, last two characters are CD. Are they equal? Nope. So it should return false or a boolean false. So now if it was AB, what should it return? It should return again. First two characters are AB, last two characters are AB. So it should return a true. Okay, let's see one more example. Let's say I just pass in AB. What should it return? First two characters are AB, last two characters are also AB. So it should return a true. So actually anything which is length 2 will return a value true. And let's take another exceptional condition, probably one with only one character. I would say my requirements are it should return false. So if there is only one character, then I can't say if the first and last two characters are the same. So anything less than 2, I don't really want to return true, I want to return false. So these are the specific test conditions that we want to write. So let's start writing our test. So start thinking about how you want to write this test. So what we want to test is these conditions, right? I have to pass in ABCD, I should expect false. So first thing, what is the name of the method that we are going to test? Is our first two and last two characters the same? So what should the name of our test method be? Think about it. How do we start writing a test? What should be the first annotation I should use? It should be add test, right? It should be add test. So because this is a test, what should be the signature of the method look like? Let's talk about first it should be public void. We have the convention of starting with test. This test is not really important these days, but let's follow the convention. In the first version of JUnit framework, there were no annotations. So the thing test in those versions were used to denote that this is a test method. JUnit came in before Java version 5. Annotations came in only in Java 5. So before Java 1.5, there were no annotations. So there was no way of putting this test tag in here. So what we used to do is in a class, anything which starts with test was kind of considered a test method. Now that we have the annotation at test, the name test does not really signify anything, but we kind of follow it more as a convention. So please, I mean, if in your project people say don't use test, yeah, do that. Not a problem at all. So let's go ahead. So the name of the method that we want to test is our first and last two characters the same. So this is test our first and last two characters the same. And the scenario I would want to write the test for is ABCD false. So I will name it as basic scenario, because that's basic negative scenario. I mean, if you can think of a better name, please do go ahead and give it. But this is the best thing I could come up with. So now what do I want to pass in? So I want to pass in ABCD to the helper, right? So I want to call helper dot, what do I want to do? Helper dot our first and last two characters the same. I would want to pass in the input. So the input is ABCD. So the first thing, is this the actual value or the expected value? Whatever this value method is returning, is it actual or expected? Think about it. So this is the actual value, because this is what is coming out as an output from the method. So this is the actual value. So string actual value is equal to this. Actually not, because it is returning a boolean. So I have to use a boolean, and I want to check what is the expected value. So expected value is, let's check what expected value is. It should be false, right? ABCD, when I pass in ABCD, the first two characters are A, B, the last two characters are C, D, so it should return a false. So let's write the assert equals. Assert equals has a lot of overridden methods. If you look at it, there are assert equals methods which would help you to test. Let's quickly bring it up again. So if I bring up the assert equals, you'd see a lot of assert equals methods: string, float, double, object, long, double. So you have a lot of assert equals methods. You can compare absolutely anything. So I can even compare boolean values as well. What's the first value I should pass? Assert equals, always the first one is expected value. So expected value, and next is the actual value. Let's go ahead and put that in, actual value and semicolon. So that's the test, right? Let's go ahead and run this test and let's see if this is running fine. We can actually do a lot better job than this. A lot of improvements we can make in here, but this is a good start. So let's go ahead and run this, and there you go, a green bar. Be happy. So we have a green bar now. Now that we have a green bar, let's try and make this test better. So the first thing is, I'll inline everything, right? I mean, I hate to see big method where it could have been done in a simpler way. So I'm doing an inline. As we discussed in the last section, it's Control Shift I, or you can do a right click, refactor, and inline. So what does the inline do? It would take the expected value. What does it have? False. So it would replace wherever expected value is with false. So now we have the simpler test. So I'll just go ahead and format it a little bit so that you can see everything in the screen. So assert equals false, comma this. So I'm saying when this method is called, I would want to expect a false in. The guys who created JUnit are very intelligent. They thought, okay, assert equals false. Aha, doesn't sound very readable, right? I mean, I'm really concerned about readable code, and assert equals false comma something does not seem readable. So can we make it better? They came up with enhancement. So they created a method called assert false. So what does assert false do? It checks if the value which is the output of this is false. Aha, that's great, isn't it? Let's right click, run as JUnit test. Okay, let's quickly look at a couple of things. Actually, the assert false directly worked because we had an import assert.star. So everything in the assert directly came over here. So if you look at the assert, there are a lot of methods in here, but the one which we used is assert false. So to an assert false, you can give a boolean value. One important thing which we didn't discuss until now is, for every test, for every assert, you can also pass in a string. So if I pass in a string, so let's say assert false dummy string, actually I should have explained something in here saying why the test failed, but if I passed in a string to any assert, when the test fails, so to make this test fail, what I'll do is I'll just say asset false and true. So I'm removing that check and I'm saying asset false true, which would fail because asset false of true, I mean, I'm saying true should return false and it would never return false, right? So this test would fail. So we'll see what happens when the test fails. Run as JUnit test. It fails, but the thing you can see is the dummy string is printed as assertion error. So if this is given to add more value, I mean, let's say asset false, the condition failed, the condition something failed. So you can have more value added to the test by doing this, and when the test fails, it would print that in here, the condition failed. Whatever message you want to put in here, you can put it in here. Actually, this was very useful in the earlier versions of JUnits and in the earlier ways of writing tests where we were testing multiple conditions in the same test. When I'm testing only one condition in one test, then I don't think the condition writing it in here is important because I know from the name of the method. So if this test fails, I don't need the condition, I mean, I don't need the text message to say which condition failed because first assertion, I mean, it's giving clearly which test failed. The test which failed, the name of it is completely here. So I know which test failed, which scenario failed because I have after the underscore a scenario name. So that's really good. And the second important thing is also the fact that when I double click in here, so if I double click in here, it would actually take you to the line where the failure was. So in any test failure, if there's a test failure, if you double click on it, it would take you to the line which failed. So in that sense, with the modern IDEs and stuff, the usage of a text message to give more description about the condition that's failing, it's not really needed. But there are still projects which use it. So if in your project you're using that, go ahead and use it. But in most of the projects, people don't use text messages to write description about what is failing. Okay, now that we had that small discussion around the text messages describing the error failures, let's move on. Similar to asset false, let's revert a little bit. This is where we were before. Okay, let's leave asset false in. Okay, this looks good. So similar to asset false, you can guess that there is something where there is an assert true. So let's go ahead and use that method now. So I'm going to write the condition for ABBB, ABAB, ABAB, and what should be the name? This is the basic positive scenario, right? I mean, this is ABAB, so matches, except the fact that instead of assert false, I want to use assert true. That's right. So assert true is what it would be. And now I can run this test, right click, run as JUnit test. And there we go. So now we looked at a couple of methods, right? We looked at assert false, assert true, and these, I'll leave the next two conditions as exercise for you. So I'll leave AB is equal to true. I mean, when I pass in AB, it should return a true, and when I pass in A, it should return a false. I'll leave these two tests as exercise for you. So just look at how you should name that test and everything else, and try and write those tests before you start with the next section. Some of the tests have some setup to do before I can really run the test. And the setup might be common to all the methods which are there in the particular class. What would be the right place to do such kind of things? That's where the at before and at after methods come in. So let's look at a quick example of a unit test with that. So let's create a new unit test for it. So let's not do it in here. Let's quickly create a new unit test for that. So I'll go to source test Java, and I would want to go to the package where we had the string helper test, and I'll create a new class. So right click, new JUnit test case. That's how we created this unit test. And I would want to write a quick test. So quick test. So I would probably call quick before after test or something of that kind. We want to learn how the before and after works. So I just leave the rest of the stuff as as defaults, and let's click finish. And there you see the first, this is the auto generated code by Eclipse, and when I run this test it would fail because there's a fail method calling not implemented yet in here. So that's good. So let's actually, what we'll do is in the test itself, I'll call this uh, test1. Let's keep it very simple, and I would actually do a sysout. Actually, it's not really recommended to do a lot of sysouts in your code. Ideally, you should be using a logger. But in like, I don't really want to set up the logging framework, so I'm going to use system out, but ideally it should be logger. So system out, I'll say test1 executed, and let's do a little bit more of setup before we try and add the before and after method. So I'll call this test2 and test2 execute. I want to understand how the before annotation works. So I want to run this method public void before, like let's call it setup. Instead of calling the before, I'll call it setup. Let's say this is either setting up some test data before executing the test. So let's say this is the executing this setup for each test. So let's call this system out. I'll call this before. How do you add, say something needs to be executed before every test? How do you do that? Try and guess. Yeah, add before is the annotation. So I'll add add before annotation. So it's in or.JUnit. If you type in add before and press control space, Eclipse would bring this drop down, and you can press enter, and then that particular import is added into the lists of imports. So there's an import or.JUnit before, and now let's see what happens. I'm going to just run this test. Okay, let's see what the output is. Right click, run as JUnit test. Both the tests would succeed. There's no question about it because there's nothing being tested, just a sysout. But you can see that whatever is in add before is executed before every test. So that's the crucial thing that we wanted to learn. So if we had some setup to do before a test, I can do that setup in the add before. So add before test would do that. So one of the ways, if let's say I wanted to create a new string helper, it's not okay for me to have one instance of string helper in here. If it was that kind of scenario where my class, I would want to create a new instance of the class every time the test runs, the way I could have done it is I could create a string helper in here, and I can create a add before method. So I can use add before, as usual I have to do an import. So I'll use Eclipse to get that import. Add before public void, the name before here does not signify anything. You could have called it setup or dummy or yeah, whatever, but give it a real good name. Don't, even though it's not important, it might be useful to have a good name there. So let's go ahead and write the new in here. So what would happen now is before every test the new string helper is created, and each of these tests would be running with a new instance of string helper. In this particular test, it's an overkill because we are not having any values stored in the string helper. It's just some kind of an utility helper class. But if let's say there was some data stored in that particular class and you want to renew the setup each time, then you have the add before. And I would have you guess what add after would do. Think about it. Yeah, your guess is very true. So it's public void. Usually we call it tear down. Let's say I created a lot of data set up for my test, and I would want to tear it down after every test. So let's say I got a connection to the database or connection to something which I want to give it back. I don't want to leave the connection open, right? So how do I do that? I'll do that using the at after annotation. Again, I can do control space and get the import in, and as you know the way we do it, sysout, and the way I got the system.out.println was sysout and control space, and you would have system.out.println. I would really recommend you to become an expert at IDE because If you understand how the IDE works, that's half the job half the job done, because as a developer, we are on the IDE all the time. So learn everything that you can about Eclipse, I guess, or IntelliJ if that's the IDE you're using. Okay, let's go ahead with whatever we are doing in here. Sys.out.println. What do you want to print? I want to print after test. Let's run this test and see what after does. Aha! Before test, test executed after test. Before test, test executed after test. If I had two more tests, then before test and after test would have been executed twice. If I have to explain them in a nutshell, before and after, these methods are run before every test method and after every test method. So the before runs before every test method and after runs after every test method. So if I have 5 tests, then before runs 5 times, after runs 5 times. That's the before and after test scenarios. We looked at the before and the after methods, right? They are executed after and before every test. There would be certain things which I don't really want to do after and before every test. I would want to do them before a class only once. So for this entire class, I want to do it once and I don't want to do it again. Those are the kind of things that you can use before class and after class for. So at before class, and let's do a control space import, yeah, that's good, and public void before class. I'll call it before class. You could have called it anything else as well. I mean, the important thing is the annotation, and the name of the method does not really matter. As our convention is, I would just call it sysout before class. Okay, let's quickly run this. Aha, what would happen? Aha, as expected, there's an error being thrown. What it says is method before class should be static. Okay, that's one thing you need to remember about before class. The before class, any method which is implementing at before class annotation should be a static method. So that means all the constraints that are around static methods as well. You cannot refer to instance variables and all that kind of stuff. So you can only have class level things initialized in here, with only really static things initialized in the before class. And now let's see what would happen. Aha, you would have seen the green bar as well as nav. You can see before class is only executed once. Before class, before test, after test, before test, after test. But the before class is only executed once before the class. And this can be used probably to initialize some database connections or things like that. I mean, I really prefer to use before and after rather than using before class and after class, unless you are really concerned about performance. So if there are some things you are doing in before and after which are taking a lot of time and you don't want to run them in every test, then you can use the before and after class. So now I used after class. Now I'll import it in. I can't call this before class, so I'll call this after class, and after class again, and let's run this. Okay, so before test, before class, and the test, another test, and after class. So before class is executed once, after class is executed once. Before test and after tests are executed as many times as there are tests in this particular class. So that's the introduction to before class and after class. So if we look at the summary of what we have learned in this particular section, we have started off writing assert true, assert false methods, and then we used at before, at after, at before class, and at after class. Let's meet in the next section. In this section, let's learn how to compare arrays. To make things easier for us, I already have a sample test created, and it's failing because that's what Eclipse brings in, a failing test at the start. So I'll remove this line. So what I want to test is really the arrays class. So I would want to actually import the array class and check the functionality whether the sorting is working fine or not. So I'm going to use the arrays.sort method in here. So there's a method called sort in arrays, which you should be knowing, I guess. So if you have an array, let's just create an array. Int numbers is equal to, let's say I have 4 different numbers. Let's pass them in: 12, 3, 4, and 1. So what would be the output if it's sorted? That's the expected values, right? Int expected values are, what would be the expected array values? 1, 3, 4, and 12, right? That's how it would look sorted. So let's first sort the array. Arrays dot sort. I want to sort the numbers. So let's go ahead and type in numbers. So arrays.sort numbers. The thing about arrays.sort, if you read the documentation, is it does a in-place sort. So it does not return anything, so it's returning a void. So whatever array is passed, it would be sorted in ascending numerical order. So it would be ascending numerical order. That's how we have the expected values. So numbers would be in an ascending order. So now I can use, how can I compare arrays? Can I use assert equals? Let's try that actually. Assert equals, I would pass in numbers and expected. Is this right? No, not really right, because ideally we should have the first value as expected and the second one is actuals. So I should have expected comma numbers. Let's do this. So assert equals numbers, expected comma numbers, and I would rename it. So test array sort, or test sort, I could have called this underscore random array, some random array, does not really matter. I'll run this test now. Aha, it failed. It's saying expected this, but it's this. The problem with assert equals, when I pass in two objects to it, is it expects them to be the same object. So it's not doing an equals on it, but it actually checks if they are really the same object. Because this array is really different from the numbers array. It's different, but it has the same values. So it's a different object in memory, but it has the same values. That the assert equals does not check. So if I want to compare the values inside the array, I should use something called assert array equals. So I'll import assert array equals. The assert array equals has very similar syntax to assert equals, except that it's assert array equals. Aha, sounds comical. Okay, let's run this test now, and now it would succeed. There you go, a green bar, famous one. Now I'll just say a wrong expected value. So I'm just changing the values so that they are not really sorted. I want to really check whether the failure is working. Yes, it's failing, and it's actually giving me a little bit of good output as well. You can see that it says arrays deferred at element 1, expected 4 but was 3. So what does it really mean? What information is it giving? The great thing about the JUnit framework is when there's a test failure, they try to be as helpful as they can. So I'll paste this in here. I don't really care about the rest of the stuff. If you look at this message which is in the log, when this failure happened, it says arrays first deferred at element 1. So array index starts with 0, right? So actually when it's sorted, this array would look like how? 1, 3, 4, and 12. So the message which came up says arrays first deferred at element 1. So this is 0. I mean, as we know, the index is 0, 1, 2, and 3. So when JUnit framework is comparing these two in the assert array equals method, it sees that at index 1 the values are different. So at index 1 the values are different. I'm expecting a 4, so the expected value has 4, but the actual value is 3. I mean, can anybody be more clearer? So I mean, when there is an error, JUnit gives me exactly what's wrong, and that's really perfect, right? Isn't it? So that's how we compare arrays. We use the assert array equals method. In this chapter, let's learn how to test exceptions. I'll copy the previous test just to make it easier for us. We want to test exceptions, so I have to create an exception. So how do I create an exception? Is what I'll do is the numbers, instead of passing in a real array, I'll make it null and do arrays.sort numbers. I'll not worry about this right now. What would happen is when I pass a null array to arrays.sort, what would happen? Do you want to guess? Run as JUnit test. What would happen is it throws a null pointer exception. So the arrays.sort, when you call it, it throws a null pointer exception. So this is a proper scenario. This is one of the requirements for arrays.sort. The arrays.sort, when I send a null array to it, it should throw a null pointer exception. So that's a proper scenario. That's a valid scenario. This is not really an error condition in here. So this is not a real code going wrong. This is really code being right, and I would want to test for this exception. So how do I say in this particular thing that the exception is expected? Typically, people do something of this kind. So you can put a try catch. So I can put a try catch and catch the exception. Let's be as specific as we can. We are getting a null pointer exception. You don't need to do anything in here because the thing is a success. So this test would succeed. Succeeds. Because now I'm expecting a null pointer exception, so the code comes in here and I'm not doing anything in here in a JUnit test. If a test does not throw an exception or it comes out in a proper way, then it's success. Absence of failure in JUnit is a success, so this would succeed. But actually a better way to do this would have been to use a specific annotation which JUnit provides. In JUnit I can say at expected is equal to the exception which we are null pointer exception dot class. This is the way I would declare that I'm expecting a null pointer exception. So what would happen? So this test is expecting a null pointer exception to happen. So when the null pointer exception is thrown, this would be fine. I mean, this would work properly. But let's just say I'm passing in an empty array. An empty array, when you sort, does not throw an exception. So what would happen? The red bar, because now I'm expecting a null pointer exception, but this is not throwing an exception. So the good thing is testing an exception. I mean, when I'm testing for an exception, I'm really expecting an exception to happen. So if an exception does not happen, it's a failure. So that's what is happening in here. I'm expecting an exception, but there's no exception thrown. So that basically means a failure. So we have learned how to test exceptions in here. We expected a null pointer exception, and we saw that when a null pointer exception was thrown, this test succeeded. And when null pointer exception was not thrown, this test failed. And in a normal test where I don't expect an exception, and if there's an exception thrown, then that test would anyway fail. It would say unexpected exception, and it would come up with the exception trace. So that's about handling exceptions in JUnit tests. Good luck with them. This would be the last chapter where we would be playing around with arrays. And now we want to test the performance of arrays. So what we want to check is, in this particular test, I want to check whether arrays sort is performing well. I want to check a few things related to performance on the arrays. So let's go ahead and start. So test sort, and let's just call it performance. If I sort one array, I don't really will be able to get the performance of it, right? I mean, it would kind of be running in less than milliseconds, probably microseconds. So it would not really give me a good variety of performance. So what I want to do is, let's say the array.sort, I would want, my performance requirement is I would want to be able to sort million arrays. So I'll write I less than equal to 1000 million, and I plus plus, I would want to be able to sort million arrays within a particular period of time. So I'll just declare an is equal to, quickly define something. I'll also introduce a little bit of variations in the array. I'll change array of 0. I'll always keep changing the value there, just so that when I'm sorting the array, it's not the same values that are being sorted. So array of the 0, I'll put it as I. And now I would want to sort the array. Here in this particular thing, I'm not really concerned about the actual expected value. I mean, I know that the arrays.sort would work because the other tests would test that scenario. Arrays are being tested. Here I want to check whether I'm able to run 1 million sorts of this particular array within, let's say, 10 milliseconds. So I want to check whether this entire array sorting of million arrays of 3 elements each is happening within less than 1 second. How do I do that? That's where there's a timeout. So I can set timeout and specify how much is the timeout in milliseconds. So let's say I want one. Let's try. I don't really know how long it would take to test this many arrays, but let's run this JUnit test and see. The test succeeds. I mean, this is incredible. So I'm able to sort a million arrays within 1000 milliseconds. Let's reduce the time a little bit. Let's make it 100 milliseconds. Still succeeds. Able to sort now 1 million arrays of this type within 100 milliseconds. Let's say that's the performance benchmark we would need to hold. So I would write this test and keep it there, so that whenever the performance of this particular array drops below this test would start failing. And this is a really good test to have when you want to adhere very strict performance requirements on certain things. So what you do is you would kind of take a little bit of buffer. So let's say I want to have this particular thing run within 100 milliseconds. So I'd put 100 milliseconds in here, and I would run a little more than what my performance requirements are. So ideally, I mean, one thing you need to really consider is the fact that this would run on a build server somewhere, and on the build server the situations might be little different. So I mean, the build server might not be as powerful as your production box. You need to take those things also into consideration before you set the timeout in here. But this is a really good test because now I can test the performance. So if I if the array.sort, somebody makes a modification and makes the performance worse, then this test would fail and alert that there's a problem with performance in this particular thing. This is how we test performance using JUnit tests. Okay, in this section, let's discuss something about parameterized tests. What are parameterized tests and why do we need parameterized? Let's start with the example which we wrote earlier. If you look at these two methods, they are exactly same except for the fact that I'm passing a different input and I'm expecting a different output. Other than that, the entire code in these two methods is the same. So how can I really make these parameters and not really keep repeating the whole thing again and again? So how do I do that? That's the problem that the parameterized tests solve. So how can I pass these values in an array and execute the test repeatedly over again? So that's the problem that parameterized tries to solve, and let's try and convert this test to use a parameterized test. What I'll do is I'll make a copy of this. So I'll say a control C, control V, and I'll call string helper parameterized. Okay, that's good. Let's open the class up, and I don't really want the before and everything in here, so I'll just put it is equal to new string helper, and I'll remove all the tests. For the first method, I'll leave them in. The second example, I would remove them out. Now, I would want to parameterize these two things. So I would pass this input, I would want to get this output. I would want to pass this input, I would want to get this output. I could refactor and create a method out of it, but if there were complex things that needs to be done in the test, that would not be an option. So JUnit supports something called a parameterized test. How do we say this is a parameterized test? That starts with a small thing. So we need to say this particular class runs parameterized tests. How do we do that? We do that by using a runs with parameterized.class. So I'll import runs with, and then I would import the parameterized class as well. So it's run with parameterized.class. That's the first step. So the first step is defining the fact that this is a parameterized test. This is not a normal test. I will not run these tests in a normal way. I'll run with a few parameters. That's what I'm putting it as, run with parameterize that class. The second thing that I would need to define is the arguments that we would need to pass. So I would want to make these arguments to the test. How do we make these as arguments that we can pass to a particular test? How do we do that? That's the next step. The way we do that is by creating one method, public. There should be only one set of conditions for a test, so it's also static, and it's a collection. I mean, it returns, your method should return a collection, and I'll just call it test conditions. On this method, this is not returning anything right now, but let's make it return something. You need to add a annotation called at parameters. That's now. Let's return null for now to just make it succeed. But what we are trying to define in here is all the test conditions. For now I'm returning in null, but we would make it to return something very soon. So it's public static collection. This name does not really matter. I just call it test conditions, and these are the parameters for this particular test. We really need to define the parameters in here. The important parameters for us are CD, AACD, CD, ACD. How do we do that? First, let's create an array with the expected input and the output. So expected input is CD, the expected input is ACD, and the expected output is CD. That's one input output pair. The second input output pair is CD and ACD. So ACD is the input. When ACD is the input, CD is the output. So this is kind of the expected input array. So I'll just create a int array with expected outputs. It's a two-dimensional array with all the conditions that I would want to check. It's a string array. When I pass in AACD, output should be CD. When I pass in ACD, the output is CD. It's the same output actually for both the inputs. So that's the expected output, but this is expecting a collection and not an array. So how do I convert an array into collection? I can use arrays dot as list, and I can pass in expected. That's great. So now I have parameters in here. I mean, it's complaining that I'm not saying which type it is. It's the warning in here. It's a collection of string arrays. So that's what we are passing in here. So I'll make it much more clearer by putting collection of string arrays in there. So now we are passing in the parameters. So we have now defined the parameters that we would want to pass. So each condition is passed in as an array. So this array contains the input and the output. Input, output. Now this test is not using these parameters. How do I make this test use the parameters that are passed in here? That's the next step. So until now we did two things, if I can summarize. First thing is we said at run with parameterize.class, and the second thing we did is we defined a collection. I mean, we defined a at parameters method which returns a collection back. So in the collection we have defined the expected input and output as a series of conditions. So now how do we write tests which use these things? That's what we will do right now. So the way the parameterized tests work is these two things are passed as constructor arguments, and a new instance of this particular test is created. So what we'll do is we'll try to create member variables in here which would accept those values in. So the first thing is string input, string expected. Those are the two variables which we need, right? To be really clear, let's make them private because we don't want them to be. Now let's generate some constructor in here. So I'll do right click, source, generate constructor using fields, and I don't need the helper there. I just need the input and the expected output. Now I have the constructor also generated in. So I have the constructor generated. So now this string helper parameterized test accepts these two as input. So the AACD goes to input, CD goes to output. So what we should do is we should now change the test to use the variables. So we created these variables in here. One is input and the expected output. So let's use the input. So the input is passed and the expected output is expected. Aha, that's good. So now I can remove the other test condition and we are all set. So if I can, I mean, if this is little confusing, that's okay. I mean, you can find this piece of class on the GitHub repository in the examples that we have, and you can look at these things step by step and do it on your own. There are three things that we did. The first thing was run with parameterized. That's the first step. The second thing was we defined the actual parameters. So what we did is we created an array of parameters and then converted it into collections and passed them as parameters. So this is the input output. So these are set of conditions. So this is condition 1, condition 2 that we wanted to test. I could add any number of conditions that I want. So that's good. So that's the second step, creating the parameters. The third step is these are actually passed in as constructor arguments. So I'm creating the constructor and storing them as local arguments. I need them as local arguments because I want to make use of them in the test. So I'm making use of them in the test and trying to run this test. So let's run this test. There you go. The first thing you can notice is this class has only one at test. But when I run this test, you'd see that it's showing two conditions succeeded. So it shows that two conditions are succeeding, 0 and 1. So test truncate A in first two positions. You can see that it's showing an index 0, index 1. So it's saying test condition 1 passed and test condition 2 also. Actually the index is 0 and 1. This is the first test condition, this is the second test condition. And let's say if one of the test conditions failed, what would happen? Let's say I passed in A, D. The output then would be A, D, just D. What would happen? So it says this condition failed. So it would also say clearly which thing failed. So if I double click, it's showing this particular thing. So the thing you need to use is the index. So index 0 failed. So it means the first condition failed. So this is first condition, index 0. This is second condition, index 1. So index 0 failed. So this is the condition which failed. So you can guess that this particular condition is the one which is failing out of the list of conditions. That's how you can use parameterized tests to write really good tests when your entire setup for the test is similar, except that the input and output that you want to check are little different to each other. So in those kind of situations, you can go for parameterized tests. The parameterized tests can be confusing when you are doing them for the first time. It's a little tricky to get the concept and implement it. So I would really recommend you to play around with this a couple of times, and also I would recommend to try and implement this as an exercise for the second example. We wrote the string helper test with booleans as well, right? So we had the booleans in here as well. So for this test, our first and last characters the same. Try and give it a try and try and write a parameterized test for it. One clue I can already give is it should be a separate class. I cannot have two different parameterized tests in the same class. So you have to create a new class. You cannot do it in the same parameterized test class because it can only have one constructor. So it cannot have other constructors. It can only expect one kind of an input. So just go ahead and try it. And if you have any questions, do leave a comment in.